In this video we're going to look at how we can use the sine rule to find missing angles in triangles. Now hopefully you already are familiar with how we can use the sine rule to find missing lengths. We know that the length of a triangle divided by the sine of the opposite angle gives us the same value no matter which pairing we use, so which side and which opposite angle. So we can use that principle to help us here, but I'm going to use the sine rule kind of upside down. So I'm going to put the angle at the top and I'm going to put the length at the bottom. So I'm going to say for this one that sine of 110 divided by 11 is equal to sine of A divided by 5. And that's just going to make it slightly easier to do the next step. If you have it the other way round, it's fine, it's just a little bit more manipulation. So I'm going to multiply through by 5, so I'm going to have sine of A being equal to 5 sine 110 over 11. So now I need to do the inverse operation of sine in order to isolate the A and solve this equation. And we do this using something called arc sine, or sine to the -1 as it sometimes gets called, because that's what it looks like. So I'm going to do A being equal to arc sine of 5 sine 110 divided by 11. So doing the arc sine of this side cancels out the sine and leaves me with A, and the arc sine of this is written this way. And I can type this into a calculator. So I've got to make sure I've got my calculator in degrees mode, and I can see that by a D up here, and I don't know if you can see on your screen, but my calculator is in degrees mode. So to get arc sine, it's the that function, so arc sine of 5 sine 110 divided by 11. And I get there an angle of 25.28575, so on. I'm going to do this as 25.3 degrees. I think one decimal place is quite accurate enough. Sort of a check you can use for this as well is if you do this and you get an answer that looks ridiculous, it could be that you've done it in radians by mistake instead of degrees, so you can always check that. Right, so this second question, I'm going to go about it in much the same way. So I'm going to say that sine of 95 divided by 10 is equal to, and then I've got a slight problem. I can't use this angle because I don't know the opposite length. So I'm just going to call this angle angle B for the minute. And I can use that, so I do know that sine of B over 6 can be used. So I'm going to solve this for B, so I'm going to then say that sine of B is equal to 6 sine 95 over 10, and therefore that B is equal to arc sine of 6 sine 95 over 10, and then I can evaluate that on my calculator. So arc sine of 6 sine 95 over 10, and that gives me 36.7 degrees. And I can use this answer to then help me find what I really wanted, which was A, because I know the angles in a triangle add up to 180. So I therefore know that A must be 180, subtract the 95, which was the angle given, subtract the angle I've just calculated. So I'm just going to type that into my calculator, and I find I get an answer of 48.3 degrees.